Good afternoon, everybody. Welcome to class today. Thank you for joining me, and got a lot of stuff to cover, so we'll have to get right into it. But before we do, just a quick kind of announcement, bit of a programming note, I guess you could say, that next week's live stream. We normally do these live streams at 2 o'clock in the afternoon on Tuesdays. Next week, we're going to have to move the live stream due to an event that I have to attend here on the campus of Cleveland Community College next Tuesday afternoon. So most likely it's going to be next Monday afternoon. I'll be in touch about an exact time later on, but I think we're looking at around 4 or 5 o'clock in the afternoon next Monday afternoon for next week's live stream, because we won't be able to have it on Tuesday like we normally do. So maybe for some of you that means that you'll be able to attend live when you normally aren't. For some of you that normally attend live, you might have to watch the recording at a later point. Either way, my apologies for having to change that, but it's just one of the things that we have to do from time to time. So this week we're talking about string manipulation. And string manipulation is one of the things that you often have to do or want to do in programming to be able to do one thing or another. And if we kind of go back and examine early on in the semester when we talked about what programming is and what algorithms do and all this kind of stuff, we talked about how an algorithm is designed to solve a computation. And we said that a computation could be a mathematical computation, which has been like what we've been working with over the past several weeks. The majority of the time, it's just been simply numeric, as it were, checking to see if, one number goes into another number or doing calculations or whatever. But we said that we could also utilize strings and checking things with strings. And this string manipulation point here is being able to take a string and to check it for different things, to run different computations on a string so that we can utilize strings to our advantage and be able to work with them a little bit better. And being able to manipulate strings is kind of a linchpin for being able to create programs. Because oftentimes, when we're working with a program, it's not just math. We have some math in there, but it's not just math. And we want to be able to do things to strings based on maybe what a user enters. Maybe we want to take part of a string and put it with another part of a string. And we can take and manipulate and push strings together or find a certain letter in a string or do one thing or another. And so we can do that with these various string manipulation techniques. Now, before we get too deep into it, let's kind of take a step back and let's talk about what is a string. Because when we're talking about a string, one of the things to examine here is, what is a string, right? What am I talking about when I'm talking about a string? And, it's a lot easier to think about when you kind of put it in perspective with other programming languages. Because in Python, we kind of take all of our data types for our variables and different types of data and such, and we kind of lump them all together. Whether it is, a string or an integer or a float or a Boolean variable, they're just kind of all lumped together as variables. But in other programming languages like Java, there's a distinction that you make between a string and other data type variables, like integers and floats, longs and shorts. For those of you who are in the programming and web development program, you'll take Java in the future. And we'll get deeper into that when we get there. And when you look in Java and you see that a string is treated differently than the rest of the variables that one might term primitives, you kind of get this understanding why. Because you have this character data type that is a primitive, and then you have a string, which is not a primitive. It is a more complex sort of data type. And so when we look at a string from that perspective, we can kind of break down exactly what a string is. Because we've talked in the past about how our computer looks at letters and how they're different, based on whether they're uppercase or lowercase, and, that specificity in, the letter that we use or the symbol that we use or what have you is significant because, each different symbol is different to our computer. It's all, they're all characters. And we've said in the past as well that whenever we put anything in between quotes, whether it's a letter or a number or a symbol or what have you, it becomes a string. It becomes characterized, maybe you could say. It becomes the character of what it is. And like, even if you went and looked on those ASCII charts that we've looked at before when we were talking about the difference between uppercase and lowercase letters to our computer, you can see that there's an ASCII value for numbers as well. And that ASCII value for the numbers is the string or character ASCII value for that particular number. Which is why we can't do numbers with strings, or why we can't do math with strings, rather. Because if you have a 7 and put it in quotes, then it no longer becomes a 7. It becomes whatever its value is on the ASCII chart to our computer. So what we have when we have a string is a sequence of characters. It's a series of characters, whether they're letters, whether they're numbers, whether they're symbols. We take them all, we put them in between. We put them in between these quotes. And the totality of all of these characters in between quotes becomes a string. And one of the interesting things about this is that when we are using this string, and one of the points that is kind of key to understanding how we work with a string, or how we can work with a string to manipulate the data results that we get from a string, is that these characters that are in a string are all arranged in a particular position. We have what we call an index location for each character that's in our string. So we have sort of an address, a home, where we can pinpoint a single character within our string. So in the understanding that a string is a sequence, we can access our characters one at a time using our bracket operator. So we see here an example where we've created a fruit, a variable called fruit. And we've given it the name of, or we've given it the value of banana. We've established this variable container. We've taken the string value of banana and we've put it inside of there. And now we're taking letter here, the term letter, the variable letter. We're assigning it fruit. So whatever string is in fruit and whatever value is at the first index location in the string fruit. And as you're looking at this, you might be saying, well, that's pretty easy to understand, right? If I go through here and I look at banana, I can count my letters and I can go 1, 2, 3, 4, 5, 6. So obviously letter is now, if it's going to be the letter in the first index location, that should be my B, right? Like that's what you're probably thinking as you watch this now, but not quite. Right? Because as we have our string here, B, A, N, A, N, A, we have all these index locations. In programming, we like to do this thing where we like to start counting from 0 instead of counting from 1. So in this instance, we can access each of the individual characters in banana. B is index location 0, A is index location 1, N is 2, 3, 4, and 5. So what it's doing is it's looking for the character that is in the first index location, which in this case is actually A instead of B, and assigning it here to the variable letter. So if this was a 2 instead of a 1, it would be N. If it was a 3 instead of a 1, it would be A, so on and so forth. And this is a crucial thing to understand as we approach string manipulation. This idea that we can access a single character or a substring of characters within an existing string. This is, one of the big power things as we're approaching this idea. Because if I can do that, I can say, well, I can check all of my letters, and I can use this ability to check all of my letters to see if they're one letter or another letter. But a little bit more about string indexing here. Another way to analyze the string is to use indexing notation. So we're indexing that reference. Or, we're using that index to reference an individual element within the string. And so we can create an index by placing an integer value inside of a pair of square brackets. Indexes always start with 0. And we can also go backwards while indexing. So we can start with -1, -2, -3. So if we have that banana, as we did before, right? B-A-N-A-N-A. Standard indexing, we go up. So it's 0, 1, 2, 3, 4, 5. But we can also reverse our indexing using negative numbers. So we can -1, -2, -3, -4, -5, and -6. Notice that when we go backwards, instead of starting from 0 here, we start at -1. That's because 0 is already taken. 0 can't simultaneously be B and A, right? So when we go backwards, it's like essentially taking this and looping it all the way around, right? So if we took this number line, like if we looked at these index locations as if they were a number line, we're just taking that number line and looping it around. So we have 0, our 0 is here, and we loop it all the way around to the end and start -1, -2, so on and so forth. So let's have a look at this really quickly inside of a REPL just to see code in action, just because I think that would be beneficial as we kind of progress. Let's see here. Where are we at? So let's just take a string. Let's do something interesting, and let's take a string from our user as an input, and then let's pass it back out. Let's pass it to another function that will give me a letter at a certain index location. Right, so let's write this program. So we're going to start with our best practices, right, which is going to be our shebang #bang /USR /bin /env Python 3. And let's write a function, and let's call it def get letter. And we'll take two arguments for get letter. We'll take the word, whatever the word is that our user enters, and we'll take the we can't use the word index, so we'll just use I for index. And so that'll be the word and the index location. And so from here, we'll just print out, or actually, it'd be smarter for us to pass it to a little temporary variable, just so we have a little extra like wiggle room that we could work with here. So let's pass it to a temporary variable called, we'll call it letter. Letter equals word index location I, and then we will print letter. So that's a little function that will get us a letter at a particular index location in a word that we define in an index location that we define as we write it. So let's add our main gate, which should be if underscore name underscore equals, and in quotes underscore main underscore. And we'll just take we'll set W equal to input enter word, and we'll set I because we can, because I here is scoped to this function, so we can use I as a variable again here if we want to. Not a big deal. Input enter index location for letter. Now, one of the things that we have to remember here is that whenever we use our input method to get a number, if we want to be able to do math or find an index location or something like that with a number, if we don't, we have to typecast it, because by default, this input method brings our data back in as a string. So that we'll wrap that in our typecast syntax. And so just like that, we have a little program here that will find us an index location for a certain word, or for a certain index in a certain word, right? So if we head over here, we enter the word tree, and let's say we want to find whatever letters in our index location 2 for our word tree. Now, before I hit enter here, I want to kind of talk about what this would look like, right? So we can write this multiple ways, right? We can even write our string and then write our square bracket operator here beside it and put a 2 in there. It would also be like saying, W equals tree and getting W index location of 2 or whatever, right? Like, we're just passing it through the program in different ways. Again, that's one of the most challenging things about programming, is that we have multiple ways that we can do the same thing. So we have the word tree here, T-R-E-E, and if we look at the index locations, that's 0, 1, 2, 3. So we should expect to see the letter E come to us. So let's give that a try. Oh. You know what we forgot to do? We forgot to call our function. Got nothing here because we forgot to call our function. That's a good opportunity to review that we have to call the function to be able to use it, right? So we need to get that. We need to call that get letter function with our W for our word argument and our I for our I argument. Now we're good. 3 and 2, and we get the letter E. And we can do that multiple times. We could apple 4, 0, 1, 2, 3, 4. That's the last letter here. That's going to be our E. Cleveland 5. That's going to be that V, or L rather. And it's 0, 1, 2, 3, 4, 5. So it's the letter in the sixth letter, but the fifth index location. 0, 1, 2, 3, 4, 5. Just a little backwards. Gives us exactly what we want. Now let's talk about something else interesting that we can do here with our index locations and write a little bit of a different program before we go further, because we can do something called string slicing. Let me see if I have a... Let's see here. Do we have... get a good slide here. String slicing. It's pretty interesting, and we can go ahead and write a little program based off of this. So when we're getting a... So that's how we get one letter, right? But what if we want to get more than one letter? We can get a segment of a string, and we can call that a slice. So we can select a slice using this sort of syntax here, where we have our string or the variable that's containing a string, the starting index location, and it goes up to but does not include the other index location here after the colon. So this will give me index locations 0, 1, 2, 3, and 4. Up to but not including the fifth. And so this is pretty significant. This is kind of cool. So let's build us a little program based on what we were just doing here with this idea of string slicing in place. And before we start doing that, let's test it a little bit. Like, we can go to our console and test these concepts. Right, so I could put in a string here like Cleveland. And if I just wanted CLEVE, that's 0, 1, 2, 3, 4. So that would be 0 to 5. And that's what we get out of that. If we just wanted land, we would start at 5. So Cleveland, we start at 5. And we can go to the end. Now, one of the great things here is that we have a little shortcut here that we can utilize, where we don't, if we want to go all the way to the end, we don't put anything after the colon. So we can start at the fifth position and go all the way to the end. And we could technically write this first one just the same as Cleveland, colon, 5. That'll go from the beginning up to but not including the fifth index location. So that'll give us Cleve as well. And so if we wanted something in the middle, like Vela, let's say, Cleveland, so our V is in index location 0, 1, 2, 3. So that's 3. And we want to go through the A, which is 0, 1, 2, 3, 4, 5, 6. We go up to, but not including that one. So we're going to go all the way to 7. And so this should return to us VELA, the letters in index location 3, 4, 5, and 6. Beautiful. So now let's write ourselves a little program based on this. So I'm going to use this same REPL here. If you are following along as you're watching this, which you probably should be, it's a good idea to get that practice in. you might want to make a new one just so you can have different ones that you can go back and refer to later. In fact, I think I want to share this with you guys later on. So I think I'm just going to comment this code out and write some new code below the comment. That way we get to keep it all in there. So what I'd like to do is I'd like to make a program called I'd like to make a Freggie program. A fruit and veggie program where we, imagine like you're a scientist and you're creating these hybrid fruit vegetables. You're going to call them Freggies, kind of a portmanteau of fruit and veggie. And so I want to take a few words off of the front, or a few characters off the front of a fruit and add it to a few letters off the end of a vegetable. So we can do that, right? So let's write ourselves a little bit of code here. So we're going to do something similar here to the way we were doing things before, but now instead of one index location to get one letter, we're going to deal with a slice to get multiple letters. So we're going to say, we'll create a function def generate Freggie. And we'll give it some arguments. We'll give it an argument of fruit and veggie. And we'll say that Freggie equals our string slice fruit. We'll slice our fruit, right? We're slicing our fruit. We're slicing our veggies. We'll take the first 3 characters of our fruit. So that's everything from the beginning of our string. So from our 0 index all the way to index 3, because it goes up to but doesn't include that last one. So that's in the characters at index location 0, 1, and 2. And so since we're going from the beginning, we can get rid of that. And we can concatenate this with the last 3 characters of our veggie. And so we'll have to do a little bit of math with this one and introduce a new little function. So we'll say veggie and then in our square brackets we'll create something using a new predefined function, which is len. Len, and inside of the parentheses for len, we're going to put veggie. So our len function, and we'll look at it in our slideshow here in just a little bit. Our len function allows us to get the length of the word. So if my word has 7 letters in it, and I run this len function and print it out to my console, that'll give me a value of 7. So if I want to get the last 3 characters, and I'm letting my user input the word, well, that might be a 5-letter word, it might be a 7-letter word, it might be a 10-letter word. I don't have control over it, so I have to use some code to be able to kind of figure out, well, what's the length of the word, and then we'll subtract 3 from it, and then we'll, kind of move on from there. But one of the things to remember here is that the length of the word is actually going to be 1 more than the letter at the final index location. Because remember, with those index locations, you start counting from 0. So we can kind of use another word to kind of proof of concept this. So if I have, say, carrot, and I wanted to keep just the rot here, len carrot is going to be 6. And I want to get the last 3 index locations, which is going to be 5, 4, and 3. So what I could do here is I could take this value, if I want to get the last 3 characters, I can subtract it by 6, or I could subtract it by 3 rather, and just let it go to the end, because that'll start me at 3, index location 3, and it'll give me 3, 4, 5. And then if my word was something different, if it was like green bean, and I ran the len function against this, well, that's going to be 1, 2, 3, 4, 5, the space count, so that's 6, 7, 8, 9, 10. 10. If we use this same algorithm here and say 10 minus 3, that would start us in the 7 index location. So that's 0, 1, 2, 3, 4, 5, 6, 7, which would be that E, E, A, N, the last 3 characters. So I know that algorithm works the way that I want it to work. So I can say len veggie minus 3 colon, and that'll give me everything from that number, the length of the word minus 3, then that becomes an index location, and I can take every letter from that index location all the way to the end. And so then we're just going to print your new Freggie and concatenate that with our Freggie. So that's good. Now we have now we almost have kind of a game here, or at least it'd be kind of a game for kids, you know. So behind our main gate, we can have our user get a fruit, get a veggie, take those values and pass them through our generate Freggie program and see what we get. So we will we'll set a variable f equal to input enter fruit. We'll take a v and set that equal to input enter veggie. And then we will take our generate Freggie function and give it the arguments of f and v. So let's say we want to take apple and carrot. So that's apple and carrot gives us an aprot. Makes sense. Maybe we want to we'll run this again. Maybe we want to take a grape, mix that with a green bean, and get a grain. So it's taking both of our strings, it's giving us a slice of each of them, and then putting them together as a brand new word. So that's one of the interesting things that we can do with string manipulation. You know, it takes the things that we've kind of been able to do before, which is just primarily calculations, and puts them into a whole new realm. And we could take not just words that we already have, but we can take words that people enter in and adjust them accordingly, you know, dynamic-like. So that's string slicing. Now, one of the other interesting things that we need to talk about is iterating over a string. So what we've done so far here is we've just kind of went through and we've looked at how we can grab either one letter or one part of a string. So we go in and we grab one part of it. But what if we want to be able to do something with every letter? Well, one of the things that we can do here is we can use our while loop that we talked about last week, along with that whole len of the word that we just discussed. So we can give it some kind of seed variable while index equals 0, like we have here in this example. And we can set, as long as that's less than the length of fruit, well, then we can take our and, display one letter out of our term at a time. And then just push that seed variable until we get to that break condition. So that's all well and good, right? That's what we discussed last week. But I'll tell you what happened I'll tell you what happened here, and it's kind of what happens in a lot of programming, is that we kind of decide that, when we do something one way a whole lot, we should probably come up with a better way to do it. Maybe we come up with a shorthand, maybe we come up with some other function, maybe we come up with some other kind of code. If we're doing something the same way a whole lot, we should probably try to figure something out. And this while loop here, where we're iterating through a string and looking at each letter in a string, we did that a lot. And there's a lot of code here. I have the seed variable. I have my while loop. I have to move my seed to get closer to the break condition. But we also have a for loop. And in Python, we have this enhanced for loop, where we can just say for letter in string. What we have here is a much simpler way to traverse our string instead of using index locations and our while loop. This is going to go through every single character in the string and do something with it. And this loop will continue until it reaches the end of the string. And that's pretty good. And one thing that we can do with this is, well, we can use our relational operators to check on our strings and see if they're the same, see if they're different, see if one of them maybe comes before another one in alphabetical order. Right, which might be interesting to do with our Fredgy program, right? Take the word that comes first in alphabetical order and put that first, whether it's the fruit or the veggie. But we can see we can use the double equals, that relational equals, to see if the words are the same. Or we can use less than to see if a word comes before another one in alphabetical order, or the greater than to see if it comes after in alphabetical order. But also remember that uppercase and lowercase letters are different, and that uppercase letters actually have lower ASCII values. So if you checked something that was an uppercase letter versus something that started against something of a lowercase letter, of that same letter, the uppercase letter is always going to come first because it's the lower ASCII value. Or vice versa if you're looking for what comes later, right? So before we get too much further, I want to talk about one thing that's going to be super important for you for your labs. And then I'm going to want to do a program, a bigger program for us together. And this thing that's going to be super important for your labs is the fact that strings are immutable, which we haven't really messed with immutability before. This means when we say that something is immutable, it means that it is unable to be changed. If we reassign a value to a variable, we have to take the entire value out and put an entire value back in. That's what we're doing with strings. If we want to change a string, we have to change the entire string. We have to take it out and reassign it a new variable. We can't change it in place. Like you might be tempted to do something like you see here, where we're changing x3, the index location of the third index location in our hypothetical word x, to be the letter k. Because, I mean, we've discussed assignment, and that should be how assignment works. But we can't just assign particular letters in a string. We have to replace the entire string, or not at all. Well, you'll get this type error if you try to do something like that. Now, we do have some methods in which we can do this, which is going to become incredibly important for you for your labs. One of which, we can use the find method. This find method looks for whether or not a string has a specific substring in it. So you could use equivalence, those equivalence operators and iteration like we're going to do in our demonstration here in a few minutes. Or you could just use this find method to see if a word contains a substring. And if it's in there, it's going to find the first instance. If you want to have it find it at a later point in a string, you can set where the index location should start looking. Now, in this instance right here, like what we're looking for in our third bullet point, we have a name equals Bob. Name.find, we're looking for the letter B. We have an index location of 1 and an index location of 2. Where, remember that whenever we're dealing with anything here, when it comes to our strings or anything that has index locations, we go up to, but we don't include that second one. So in this instance, we have BOB, that's 0, 1, and 2. So the only term that this find code here specifies is for that O. Because it's starting at 1 and it goes up to but not including 2. So everything that's up to but not including 2 is still just 1. Right? So that's 0, 1, 2. So that's O. And the result of this gives us a -1. And this is a failure in the find method. Since the letter B is not in that range, we get a -1, and that indicates a failure. But this gives you a good idea as to what you could do if you're going to use the find method to check to see if a character or a substring is in a word. Because you can essentially check to get the result. And if the result is 0 or greater, if it's in the index somewhere, well then it's there. If it's less than 0, then it means that it was not found. And you can go on to the next thing. We also have the replace function. Now we'll talk about the replace function here. Now, one of the important things to note about the replace function is that when we're looking at the replace function, that's not replacing characters in the string the way you might think. Like, because we just said strings are immutable and you can't replace characters in place. What this actually does is it makes a copy of the string in memory where it adjusts all of the characters that you're looking for and changes them to the ones that you want to change them to prior to kind of committing that string to memory. So in this instance here, we have a variable created called y. Y is some string, whatever we want it to be. We set a variable x, which is a new variable because we have to take this copy and put it somewhere. We can't put it back to y because strings are immutable. So we have to create this new variable. Y.replace, we're replacing s with y. So then when we print x, we get yom yitring because we've replaced those s's with y's. And so that's good. Now what I'd like to do is I'd like to kind of wrap up our live stream today with a program. So I got this password scoring program. As you do with coding assignments from time to time, we give it a fake scenario. So let's give this a fake scenario. Let's say the PSO, the Password Security Organization, would like for you to create a program based on their new algorithm for evaluating passwords. The program should look at each character in a given password, evaluate it based on the type of character against a set of predefined conditions, and then give it a score. Optionally, they would like for you to give it a rating along with the score of poor, good, or excellent. So we have something here that's kind of similar to what we did a while back when we looked at the moose. But here's the brief that has that algorithm in it. So we want to be able to take an input of a password from a user. So we want to be able to use that input function here. We want to score 1 point for every lowercase letter, 2 points for every uppercase letter, 2 points for every number, 3 points for every symbol. And then here, this is interesting, if each element is proportionate, we want to take and multiply the final score by 1.5. So if you have an equal number of lowercase, uppercase numbers and symbols, we take and we multiply the final score by 1.5, and then we display the password score in the console. So what you might want to do if you're following along here, if you're doing this later especially, pause the video here, write down this brief, write down the key points here, so you can remember them as we go throughout actually writing this code. So what I'm going to do here is I'm going to create myself a new REPL. File, new REPL. CIS 115 OL Spring21. Password. Judger. That should be in the name. I don't know why I like to do that so much. Python should be the language. Make sure we got the right name in there. Put the name in there. There we go. Now we can start to write this code. So what I'd like to start by doing here is I'd like to start by just doing our best practices. So we're going to add our shebang. And we'll add our main gate later. So what I want to do is I want to write a function that's going to score that word, give that word a score. Based on that algorithm that we saw from our slide there. 1 point for every lowercase letter, 2 points for every uppercase letter, 2 points for every number, 3 points for every symbol. Right, so let's Let's create a function here. Def, we'll call it score word. And we'll need to be able to bring the word in, so we will bring that word in as an argument. And I think what we want to do here is we want to check some... We want to check some strings against some other strings. So what I could do is I could kind of write my lowercase letters and set that equal to the lowercase alphabet. A, B, C, D, E, F, G, H, I, so on and so forth. We have a library that's taking care of this for us. So instead of that, we're going to import string. We're going to import our string library. And we're going to use string dot ASCII ASCII underscore lowercase. So this is interesting, right? If we print LC now, we can see what the result of that is. It'll take just a second. We might have to refresh this REPL because it looks like it might have frozen up here. Let's refresh you. Love REPL. That's the only thing I don't like about it from time to time when it gets kind of hung up like that. You see, it got rid of my code. It didn't even save my code. Let me just write this code back in really quickly. We want to import string. No, not that. Import string. And we'll define score underscore word with word. We will set LC equal to string dot ASCII underscore lowercase. And then we will print LC just so you can see what it does. Actually, I want to do that inside of that function. And then we'll call that function. Oh, we need to make that a string here as we call it. So it just gives us the lowercase alphabet, right? That's what it gives us. Gives us lowercase alphabet. We can also use an uppercase alphabet here, so we can say UC equals string dot ASCII uppercase. It just saves us from having to type out every single letter. Now let's create a string of symbols. So we create a string called sim, and we'll set that equal to just a bunch of symbols. Maybe all of these. Maybe some of these. Actually, I don't want to use that slash character. This particular IDE is having some trouble right now. Maybe my connection's not so great. Let's type my symbols back again. We'll get rid of some of these just to try to keep it nice and neat. Just because there, I think that's probably enough symbols. We have them all in a string. And let's create a string of our numbers. And we want these numbers to be in a string. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And since we're having to score a word based on a different value for each of these, we need to create a score variable, something to hold our score. Now, what we could do here is we could use one score variable, but we're also checking for something else, which is we're checking for that proportionality. So if we use 4 score variables and just add them together at the end, then we could use one set of variables to track both proportionality and the score. So let's use an LC score, and we'll start out by setting that equal to 0, a UC underscore score, we'll set that equal to 0, a sim underscore score, we'll set that equal to 0, num underscore score, and we'll set that equal to 0. And so now we'll just write ourselves a quick little for loop here. And we'll say for letter, and this is just a variable name. When we're writing this enhanced for loop, we can make it whatever we want. We can make it, one of the things that I like to do is just write like for letter in whatever, just so I know that it's going through every letter. It just kind of makes things clear. But I can make this word here that's letter, I can make it whatever I want to make it. It's just a variable name. But for letter in word again coming from our argument, so we're passing this value into our function. If letter in LC score plus equals 1. So we'll check our string here, that's LC, that's all of our lowercase alphabet. If it's in there, we'll add 1 to here. Otherwise, elif letter in UC, well, we'll add our UC underscore score plus equals 2, because we wanted to give that 2 if it was an uppercase. Elif letter in sim. Symbols were worth 3 points. So sim underscore score plus equals 3. And numbers were 2 points. So elif letter in num. That's num score plus equals 2. And there are some characters that aren't dealt with in our 4 strings here. Like you notice we don't have slashes, we don't have quotes. If it's one of those, which most passwords don't use anyway because those are so heavily used in programming, we just won't worry about it. We'll just give it a 0. So now we'll create a variable called final score. And we'll set that equal to all of these scores put together. So that would be LC score plus UC score plus sim score plus num score. Which is good. So what we can do here is we can take these other values, check the proportionality to see if they are in equal proportion, right? So we can base everything on this LC score since those are all 1 pointers. So 1 point in LC score means we have one character of that. So we could say if LC underscore score equals UC score divided by 2 and LC score is num score divided by 2. So we're basing everything on that LC score, right? Because it's, you know, if everything is equal to LC score, that means there's a proportional amount. We're just dividing the number of points that these things are worth. So we get a number of letter amounts here. And so with that, we can check to see. We can just put another and LC score is sim score divided by 3. In this case, we will take final score and multiply it by 1.5. And then we can return that final score value. So we'll make this a value function and just return the value back out of it. So this is a fairly complicated algorithm. Might take you some time to sit here and pore through it. You know, if you're trying to work it along with me, this is one of those places where it's a great idea to kind of pause along the way, rewind if you need to, all that sort of stuff. But now behind our main gate, we can test this out. So we'll add our main gate if name main. We'll take an input from our user. We'll set W equal to, or no, it's a password, right? So we'll set password equal to the input of enter password to check. Then we will print the results of our score word function with password as its argument. So we do have one more thing here that we want to add to this because we wanted to rank that password, right? But we want to test this first before we go any further, just to make sure that our algorithm works. So one of the easiest ways that we're going to need to do this is to just take a password that we know kind of meets the criteria and run it in there. So let's say we run just the word apple. APPLE. That's 1, 2, 3, 4, 5 letters. They're all lowercase. So we should get a 5 returned to us. We get 1. What did we mess up here? Well, I'm sure I have a typo in here somewhere. You're probably out there. You're probably looking at it. And you're probably saying, "Oh, I see the error, and I am completely missing it." Where I've made this typo. So you know what I'm going to do instead, in the interest of time, since I am fairly certain it is just a typo, I'm going to take the code from my working copy and just paste it in. Now let's try that. That's better. Typo in there somewhere. Well, I have this in another window, and I was trying to follow it, and obviously I missed something there. Little typo. So now we can check to see everything looks exactly the same right offhand. I just typoed somewhere. You probably caught it. I didn't. It's late on a Monday or late on a Tuesday. Let's try something else. Let's try to all caps it. So that should be 2 points per letter, so that should be 10. If we enter all exclamation points, that should be 2 points, or that should be 3 points a character. So if we have 1, 2, 3, 4, 5, 6 exclamation points, that should be 18. Good, good, good. And if we enter in some numbers, that should be 10. That's good. And if we enter in one of each, so lowercase a, capital A, exclamation point, number, that should be 1, 2, 3, 4, 5, 6, 7, 8 times 1.5, so that should be 12. Boom. Very good. 12. So now that we have that, we can create ourselves a rank function. So let's just create a def rank underscore password, and we'll use the score that we get from our other function. And we'll say if we'll create an empty rank variable, set it to nothing. We'll say if score is less than, or if score is greater than 0 and score is less than 20, we'll set rank to poor. Elif score is or elif score greater than 20 and score is, and this should actually be score is greater than 19. Because remember that when we use greater than and less than, it's up to but not including, so that would be greater than 20 would be 21 and up, so we wouldn't actually cover 20 there. And score is less than, let's say, 50. Well, we'll say that is a rank equals good password. Elif score is greater than 49. We'll rank that as excellent. And then we will return rank. So now we can enter our password. We can print the score of our password. We can, it'd probably be better to take and put this in a variable so we could use it when we call this rank password as well. So let's call it, let's create a variable called score and set that equal to that. Then we can create a variable called, let's say, pass rank, and set that equal to rank password with score. And we can just print out your password score rank pass rank. And so that finishes us off here for our program. So if we run something like Apple, oops, we tried to concatenate integers with strings. We can't do that. We need to typecast here. Even after you've done this a million times like I have, sometimes you still forget. It's okay. Remember that the important thing to do is to be able to look at these error messages so you can remember what you did wrong. We'll run this Apple password 5 rank poor. We'll add another space before rank here so we get space here. So what I've got here in another window, I have a little secure password generator that'll generate a random password for me. So let's generate a password over here. Let's copy it. And let's paste it into here. And so that password gives me a score of 40 and a rank of good. So we can see it working here. So we've already gone way past our normal hour of schedule for today. So we'll just leave this here. You can kind of tinker with this further, tinker with the code, see where it works, see what you might want to change, that sort of thing. I'm going to turn the music back on and just hang out in the live stream chat for just a couple minutes, just in case anybody has any questions. But that is all that I have for you for this week. Thank you for watching. We'll see you next time.